Hi, my name is Alif Mukris.
Hi, I'm Noelia.
Hello, my name is Sheikh Hussein Al-Hadi.
Hello, my name is Nursha Zuramani.
And together,
We are
Bellatrix.
Bellatrix. In this video, we will be presenting our Robosim Professional Round project called Jarvis. Jarvis is an obstacle avoidance robot which is designed to navigate in an unknown environment by avoiding collisions. Jarvis senses obstacle in the path, avoids it, and continue running. From the instructions, we need to build a robot which be able to avoid obstacle from left, right, front, and mixed barriers.
For the components, we are using Arduino Uno, breadboard, motor driver L293D, 3 pieces of ultrasonic sensor, a pair of hobby gear motor, and lastly 9-volt battery.
The robot circuitry starts with wiring the Arduino's 5-volt pin to the breadboard's positive terminal and Arduino's ground pin to the breadboard's negative terminal. Next, the wiring for the L293D motor driver IC starts with wiring its ground wire to the negative terminal on the breadboard. Output 1 and output 2 pins were wired to the left motor. Output 3 and output 4 pins were wired to the right motor. Enable 1 and Enable 2 pins were wired to the Arduino's digital 5 pin, while Enable 3 and Enable 4 pins were wired to the Arduino's digital 6 pin. The input pins of the motor driver, which are input 1, input 2, input 3, and input 4, were wired to the Arduino's A1, A2, A3, and A4 pin respectively. The power 1 pin is wired to the breadboard's positive terminal, while the power 2 pin is wired to a 9-volt battery's positive terminal. The negative terminal of the 9-volt battery is then wired to the negative terminal of the breadboard. We utilize 3 ultrasonic sensors for our project, with each being positioned either at the front, left, or right. Each sensor has their power pin wired to the breadboard's positive terminal, and their ground pin wired to the breadboard's negative terminal. The difference lies in the connection of each sensor's trigger and echo pin. The front sensor's trigger pin and echo pin is wired to the Arduino's digital 11 pin and digital 10 pin, respectively. The left sensor's trigger pin is wired to the Arduino's digital 13 pin, while the sensor's echo pin is wired to the Arduino's digital 12 pin. The right sensor's trigger pin is wired to the Arduino's digital 4 pin, and the sensor's echo pin is wired to the Arduino's digital 3 pin. And that's basically it for the wiring of our project.
Hi, I will be taking part for the coding. So firstly, go to variables, create variable to front sensor, left sensor, and right sensor. Then take set variable to numbers for 3 pieces. Change the variables. Now go to input and take the read ultrasonic distance sensor on trigger pin and echo pin. For front sensor, set the trigger pin to 11 and echo pin to 10. For left sensor, change them to 13 and 12. And for the right sensor, set it to 4 and 3. It is based on the circuits we made. So now we are going to make the coding for the left sensor first, which means the obstacle is on left. So we want the robot to turn right. To make it, the right motor should stop and the left motor have to move. So go to control, take if else block, then go to map, take this diamond block. Change the operation to more than or equal to. Put the variable which is left sensor and change the numbers to 20. It is based on the instructions which says 20 centimeter. Now go to output, take 2 pieces of set pin to numbers and 4 pieces of set pin to high or low. The first two of blocks are for enables, so set them to 5 and 6, while the inputs, change them to analog 1, 2, 3 and 4 respectively. Now, since we want the motor to turn right, the left motor should be at speed 127 while the right motor should be 0. And for the inputs, the first analog must be high and the others should be low. Now go to control and wait 2 seconds and put it below. Now after the robot turn right, we need to make it go straight again. To make it, duplicate the blocks. For enables, set the both enables for 255, which is maximum speed. And the analog should be high, low, high, low. So next, we are going to make the coding for right sensor. Choose the same block as before. This time, put the right sensor variables. For right sensor, it is the vice versa of left sensor. So the left motor should be 0 and the right motor should be 127. While the inputs, the third inputs must be high and the others are low. Same as before, after we make the robot turn left, we need to make it go straight again. So we just need to duplicate the coding. So now we are going to make the coding for front sensor, which means the obstacles is from front. So the robot need to stop, reverse, and turn right or left. To make it so, do the same thing as before. Now, to make the robot stop, both enables must be 0 and all the inputs should be low. After that, we need to make the robot to reverse. So duplicate it. Change both enables to 127. And the inputs is vice versa for the go straight blocks, which is low, high, low, high. Then we need to make the robot to turn right or left. Now we choose it to turn right, so we just need to duplicate from the left sensor. The same as before, make it go straight again. Now we are going to make the code for mixed barriers, which means the obstacles are from front, left, and right. For these mixed barriers, the robot must be stop, reverse, and turn back. To make it so, it's just the same thing from front sensor, but we need to make it turn right 2 times because we want it to turn back fully. So take this diamond and block and put in the same blocks before to each chambers. Put each variables. Now, to make the robot stop and reverse, we just need to duplicate the blocks from front sensor. And as I said just now, it is the same as front sensor. We have to make it turn right by 2 times. Take another set of code blocks from left sensor. And that's it. We're done. That's all from us. Thank you.